Hey guys, tonight we drift beyond sound itself. You're floating slowly, steadily, just past the familiar glow of our solar system. There's no wind here, no bird song, no hum of traffic. The silence is so complete it wraps around you like a thick woolen blanket. Your breath doesn't echo. Your heartbeat doesn't carry. The only sound you hear is the faint memory of Earth still ringing in your ears, like the buzz after a concert you barely remember. You tilt your head slightly, pointlessly, but still, and fix your gaze on something darker than space itself. A spot in the void that doesn't shimmer, doesn't blink, doesn't move. It just waits. It's a black hole. And if you're close enough to see one, well, you probably won't survive this. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And I'd love to know, where are you watching from and what time is it there? Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're not falling, not yet, but the sensation creeps in. Your center of gravity feels woozy. Your stomach dips. The black hole doesn't move, but you sense its pull like a magnetic itch under your skin. You've read the basics. It's a point in space where gravity is so strong, nothing, not even light, can escape. But gravity isn't a sound, right? Here's where things get slippery. Sound is just vibration waves passing through a medium like air or water. In black holes, they gulp the medium, crush the particles, and spit out nothing. So how do you hear a thing that doesn't let anything out? You don't. But theoretically, you might feel it. You might imagine it. And as it turns out, a lot of scientists have tried. You continue drifting inch by inch toward the event horizon, the point of no return. It's not a visible line, but more of a threshold in physics. On one side, information can still escape. On the other side, you might as well mail your atoms goodbye postcards. Historically, the first person to suggest anything like this was John Michell, way back in 1783. He was a natural philosopher with what we might generously call unusual foresight. Using Newtonian mechanics, he speculated about dark stars, whose gravity was so strong even light couldn't escape. The idea was mostly ignored at the time, possibly because it sounded like a 5th century fever dream. But hey, points for ambition. Modern black holes came later, with Einstein's general theory of relativity in 1915. His equations didn't say black holes exist outright, but they did suggest that under certain conditions, space could fold in on itself. In 1939, Oppenheimer, the same guy who'd eventually turned deserts into radioactive nightlights, proposed that massive stars could collapse into something so dense that not even light could leave. Cue theoretical mic drop. Now back to you, still drifting. The odd thing is, the closer you get to the black hole, the more time begins to misbehave. Your internal clock ticks normally, 1 second, 2 seconds, but Earth's clocks are sprinting ahead. If someone were watching you from a safe distance, they'd see you freeze just before the event horizon, like a bug caught midair in amber. That's gravitational time dilation. It doesn't feel like anything, but it does add a delicious absurdity to your situation. Now imagine just for a moment that sound could reach your ears here. What would it be? Some theorists suggest it wouldn't be a roar or a scream, but a low, bottomless hum like a cello string stretched across the universe. Because a black hole isn't empty, it's a glutton. It feeds on gaseous, dust, stars, even other black holes. And as this matter spirals inward, it forms what's called an accretion disk, a fast-spinning saucer of incandescent doom. And that disk? It moves. It vibrates. It shakes space itself. You don't hear it, technically, but if you could, scientists say you might pick up something like a deep rumble far below what any human can detect, like a choir of iron bowls rolling down a hill of velvet. Meanwhile, fun fringe idea. A few alternative thinkers, bless their cosmic curiosity, once proposed that a black hole could ring like a bell if struck by a gravitational wave. Historians still argue whether Einstein himself found this plausible or thought it was mathematical gibberish. Either way, the math didn't care. And here's a quirky tidbit. In 2003, astronomers using NASA's Chandra X-ray Observatory found ripples in a galaxy cluster's gas actual pressure waves. The frequency? 57 octaves below middle C. Translation: that's a B-flat 1 million billion times deeper than you can hear. The universe basically whispered bass notes into a cosmic pillow and nobody noticed for a few billion years. But don't get too cozy, you're not at the event horizon yet. You feel a gentle tug, not pain, not pressure, just gravity slowly personalizing itself to you. If your feet are slightly closer to the black hole than your head, they'll start to fall faster. That's called spaghettification, and yes, it's just as charmingly terrible as it sounds. Over time, your body stretches like taffy, or linguine, if we're being honest with ourselves. But hey, you won't feel it for long. Here's the odd part, though. The black hole doesn't suck you in. It waits. It lets space fall into it. You're just riding the river. If you had a way to transmit signals outward, say a fancy little speaker strapped to your chest, and it could somehow survive, your descent might actually create a Doppler-shifted audio trail, like an ambulance driving away forever. The pitch would drop lower and lower as your voice slowed to an impossible crawl until it was nothing but a final cosmic sigh. And somewhere someone might hear it. But that's wishful thinking. No sound travels in a vacuum. No cries echo past the horizon. And if you're still clinging to the idea that sound must require ears, maybe you're missing the point. Out here, the universe sings in frequencies you weren't built to hear, but that doesn't mean it's silent. You just have to know where to listen. You're falling now, not floating, not drifting, falling. Space doesn't have an up, but your body swears it's being pulled downward, as if some invisible escalator beneath your feet has started moving faster than your legs can keep up. The black hole looms larger, or maybe it doesn't. Maybe it's just swallowing the light around it so thoroughly, your brain fills in the blanks with panic-colored guesses. Still no sound. Just that internal hum, the one your ears invent when things get too quiet. The accretion disk glows like a smear of melted gold circling a drain. You wonder if it would hiss or roar if it were close enough. On Earth, hot gas screams. Here, it only shines. Trillions of particles crashing at near light speeds, generating more energy than a million suns, and you hear exactly nothing. This is what it means to scream into nothing. Let's talk about that scream. When matter falls toward a black hole, it doesn't just plop in politely. It spirals. It tumbles. It collides with itself and heats up, reaching millions of degrees. If sound could survive this violent ballet, it would be deafening. You'd hear the crackle of atoms being shredded, the clash of magnetic fields twisting into knots, and the soft, wet thud of physics abandoning its dignity. But it's all happening in vacuum. So, again, no noise. Still, your imagination plays along. You picture sparks flying off distant rocks like fireworks in reverse. You hear the sizzle of plasma, even though your ears are as useless here as sunglasses on a jellyfish. Quick historical detour. In 1964, Russian physicist Yakov Zeldovich proposed that a rotating black hole could actually amplify waves, kind of like shouting into a megaphone made of warped space. It wasn't just science fiction. Years later, British physicist Stephen Hawking expanded on this, suggesting that black holes might not be entirely black. They could leak tiny amounts of radiation, now called Hawking radiation, over vast amounts of time. Imagine the black hole slowly evaporating, not with a bang, but with a soft, never-ending certainty. Now picture this. You're closer to the event horizon than ever. You'd think things would get louder, but here's the irony. Inside the black hole, the universe grows quiet again. Not just soundless, but stripped of dimensions that used to make sense. Space folds in, time turns inward. It's not a place anymore. It's a direction you're being forced to go. Scholars still argue whether the laws of physics survive past this point. Some believe a singularity exists at the center, a point of infinite density, where the known rules break down like a teenager's first car. Others think maybe black holes are just gateways to new universes, where time resets and matter gets another shot at existing somewhere else. Fringe theory alert. One 20th century mathematician named Roger Penrose floated the idea that black holes might contain trapped surfaces, regions where light moves in endless loops. If you could record those loops, maybe you'd catch echoes of every star, planet, and podcast ever consumed by the black hole. Kind of like a cosmic voicemail that never gets deleted. Quirky fact. Some researchers once wondered whether advanced alien civilizations could harness black holes as soundless engines. Not to travel too messy, but to store and transmit information using gravitational waves. Think of it as Morse code using space-time itself, the ultimate whisper network. But back to you, if this were a Hollywood movie, this is where everything would start shaking. Sirens, red lights, a symphony of doom. But instead, nothing, not even a thump. The laws of motion haven't forgotten you, they're just too warped to help. There's a strange intimacy in the quiet. You're wrapped in cosmic indifference, and yet you feel seen, like the universe is gently saying, "Oh, it's you." And you start to wonder what it would take to actually hear the black hole. Maybe not with ears, but with instruments, simulations, wild imagination. Turns out we've tried. NASA has sonified data from real black holes, turning X-ray readings from things like the Perseus cluster into audible sounds. The result? A low, eerie moan, like a choir singing from behind a mountain. These aren't real sounds, of course, but they're mapped onto frequencies we can hear, so our minds can connect. Imagine the wind howling through an empty cathedral. That's what a black hole might sound like if your eardrums were a few trillion times more sensitive, and if you didn't disintegrate first. One more thought. In 2015, scientists using LIGO detected gravitational waves for the first time. These were literal ripples in space-time caused by two black holes merging over 1 billion light-years away. When those waves reached Earth, they lasted only 0.2 seconds. But in that blink, space flexed, time hiccuped. And when scientists converted that data into audio, it made a little chirp, just like a bird, or a kid tapping a tuning fork against the universe. Not the roar you'd expect, right? Instead, it was quiet, neat, almost polite. You smile if smiling's still an option this close to gravitational doom. Maybe that's the real joke. You've spent your life on Earth dodging noise-ringing phones, loud buses, late-night neighbors with mysterious drum kits, and now that you're finally somewhere truly silent, you want to hear something. Just one cosmic thud, a universal whisper, proof that you were here. Instead, you fall deeper. Not faster because time's begun to split in two, but deeper. Your atoms begin to stretch. You imagine them like a jazz band slowly losing sync. Trumpets going one way, basses the other, everyone's still technically playing the same tune. And through it all, no sound. Just gravity, rewriting the lyrics. The light behind you fades. That's not poetic, it's literal. Photons can't keep up anymore. You've passed the photon sphere, the last place where light can orbit without falling in. If a beam of light could loop around a black hole forever, this is the track it would take. But even here, nothing lasts long. The universe outside starts to blur. If you tried to look back, you'd see a halo of distorted galaxies smeared into a swirling ring. That's gravitational lensing space itself bending like old glass. Everything beyond you is being warped, pulled, funhouse mirrored into submission. And ahead, still nothing. Not black, not dark, just absence. But you remember that word, event horizon. That invisible boundary you're crossing now where not even light can escape. From here on out, you are falling into history. And if history could echo, this would be the place to listen. Because even if you can't hear anything, black holes do make waves, just not the kind your ears were built for. These are gravitational waves, tiny ripples in space-time caused by cosmic events too massive to comprehend. Two black holes merging? That makes a ripple. A star getting torn in half like soggy paper? That too. It's not sound in the traditional sense, but when we translate the frequencies of those waves into something audible, sonify them, they can make your spine tingle. Imagine a whale song buried under a mountain, or a heartbeat recorded from a dying god. In 2015, when LIGO first detected those gravitational waves, it was like the universe had picked up a microphone for the first time. Scientists listened to the merger of two black holes, 1.3 billion light years away, and what they got wasn't a boom or a scream, it was a chirp, a soft little bloop. Not exactly the dramatic thunder of colliding giants, but a sign that space-time itself had flinched. And remember, that chirp started as gravity. Here's something strange. Black holes can ring like cosmic bells. This is called quasi-normal ringing, and it happens after a black hole merger when the resulting black hole settles into its new shape. The space-time around it vibrates briefly like a struck gong before it relaxes into silence. The pitch of that ringing, it depends on the mass and spin of the black hole. It's unique. It's like a fingerprint. So technically, every black hole has its own song. You just don't have the ears for it. Quirky note. There's a theory that supermassive black holes, like the one at the center of the Perseus cluster, can produce waves in the surrounding gas that stretch across hundreds of thousands of light years. When NASA translated that data into audible frequencies, it revealed the lowest known sound in the universe, a B-flat, 57 octaves below middle C. If you played that note on a piano, you'd have to expand the keyboard across a football field and then some, which frankly sounds like something an alien jazz band would do just to flex. But how do we know this? Well, for starters, we listen with everything but ears. Telescopes that see X-rays, detectors that sense changes smaller than a proton, simulations built from math stranger than fiction. We're turning whispers into waveforms, pressure into pitch, light into lullabies. Historians still debate who first imagined a black hole could create a detectable signal. Some say it was Hawking, others point to obscure papers from the Soviet Union. Like many ideas in physics, it probably began as an argument over tea or vodka. Regardless, what we now know is this. Even the quietest parts of space can be mapped like music. Let's talk collisions. When black holes crash, they don't do it gently. They spiral toward each other faster and faster, warping space-time with each rotation. Picture two Olympic figure skaters holding hands and spinning until the ice melts under them. But the ice is space, and the skaters are millions of suns in weight. And instead of applause, the universe just shivers. In those final seconds before merging, the gravitational waves spike the chirp scientists here is the moment of impact, like the beat drop in a celestial song. Then comes the ring down, that slow fade out as the new black hole adjusts to its existence. You're thinking, so what does it sound like really? Well, try this. Close your eyes. Now imagine a slow, rising tone low, almost imperceptible, climbing higher and faster until it suddenly pops. Then the air seems to suck inward, and a fading hum trails off into silence. That's roughly what the first detected wave sounded like when translated. A little anticlimactic maybe, but also impossibly elegant. And you're right in the middle of it now. Inside the event horizon, the laws get murky. You don't hear, see, or feel in the ways you used to, but let's assume, for the sake of a thought experiment, that your consciousness is still intact. Somehow, suspended in this frozen moment, you become the perfect observer. You don't move forward, you just are. And all around you, the black hole hums, not with sound, with meaning. Imagine every object it's ever consumed, the remnants of stars, torn fragments of planets, unfortunate spaceships resonating faintly within its structure. Not physically, but gravitationally. Each with a tiny contribution to the black hole's shape and spin and tone. And you're becoming part of the harmony. One more note in the song no one can hear. Here's a question some scientists love to ask in low-lit conferences. What if black holes preserve information? According to the laws of quantum mechanics, information can't be destroyed. But when something falls into a black hole, where does the info go? The mass? The identity of a thing? Some theories say it's encoded in the event horizon. Others argue it's lost forever. Still others think it comes back out eventually, as scrambled radiation. Like burning a library and trying to reassemble the ashes into Shakespeare. One of the most debated possibilities is that gravitational waves carry not just energy, but clues, tiny imprints of the structure of whatever caused them. So maybe, just maybe, we're not just listening to collisions, we're hearing encrypted stories. And you're mid-sentence, you're becoming part of the next wave. No one will hear it, but it will be there. Time by now is doing something very weird. Not just the usual minutes feel like hours thing. This is deeper. You're stretched across moments one version of you still hovering at the edge of the event horizon, frozen in the act of falling. Another version, if we take the math seriously, is already deep inside, hurtling toward whatever waits at the core. Both are you. Both are true. Einstein would nod, then sigh, and then remind you, this is what general relativity promised. It's not just spooky, it's elegant, like ballet, but with math. And then somehow you start to feel it, the memory of sound, or the ghost of one. You're not hearing with ears anymore. Those stopped working a while back, along with breathing, blinking, and anything else that depended on a nice, predictable universe. But the mind improvises, especially when it's confused and falling. So here comes the phantom hum. It's low, continuous, not quite a vibration, not quite a song. It feels like it's coming from inside your bones, except your bones are now theoretical. You think it might be the sound of your atoms separating, if such a thing had acoustics. Or maybe it's just your brain reaching for familiar patterns in unfamiliar silence, like a toddler calling every animal dog. This might sound absurd, but here's a real thing. Some researchers believe that gravitational waves might be used one day to map the insides of stars. Not like gravity. These are the ultimate non-invasive tools, the universe's way of whispering what's happening behind closed curtains. So you imagine your body as one of those stars now falling apart quietly, broadcasting its final structure in gravitational poetry, the ultimate overshare. Let's pause here to admire a historic oddball. Carl Schwarzschild. Back in 1916, while dying of an autoimmune disease on a World War I battlefield, he solved Einstein's field equations and came up with the first exact solution that described what we now call a black hole. He didn't live to see what his math would mean. But today, his name defines the most basic kind of black hole, a non-rotating, uncharged one, a cosmic blank slate. If he could see you now, he'd probably raise an eyebrow, maybe two. And yet, what you're falling into isn't basic. It's spinning. You can feel that not with balance or motion, but with geometry, as if the space around you is being stirred like honey in slow motion. This is a Kerr black hole, and it doesn't just sit still and pout. It rotates. It drags space-time along with it, twisting everything in a direction called frame dragging. Quirky fringe alert. Some folks have proposed that in the spinning chaos of a Kerr black hole, there might be pathways, tiny, temporary tunnels through space-time. Wormholes, essentially. Not the Hollywood kind with worm guts and blue lightning, but slippery mathematical possibilities. Some argue they'd collapse instantly. Others suggest they might allow a one-way trip to a new region of the universe, or an entirely new one. Of course, that's assuming you survive, which again, you probably won't. But it's nice to be included in the discussion. Back to the noise that isn't. If you could hear gravitational waves directly, and if your body hadn't already been turned into conceptual spaghetti, you'd be surrounded by constant, overlapping vibrations. Not like sitting near a speaker, more like being the speaker. Your entire form oscillating in response to distant collisions, black hole mergers in other galaxies, neutron stars smacking into each other like sleepy marbles, ancient cosmic events that happened before the Earth cooled. Historians still debate whether ancient astronomers had any inkling about gravitational phenomena. Of course, they didn't call them gravitational waves, but some scholars point to Babylonian star charts, which describe periodic stellar brightening that we now suspect came from binary systems, stars locked in tight, invisible dances. Perhaps they sensed the rhythm, even if they couldn't name the tune. And here you are now in the deepest part of the verse. inside the one place no rhythm should escape from. Yet it all feels weirdly musical. You remember a paper you once skimmed, something about black holes vibrating like drums. Not metaphorically, literally. A simulation had shown that if you could perturb a black hole, give it a little push, it would ring. Briefly, deeply, in frequencies that depended entirely on its size and spin. One note, one object. The physics equivalent of a tuning fork. Now you wonder, are you the push? Is your fall into this place sending out the tiniest ripple, a barely there ping in the fabric of space? Are you ringing the bell of the cosmos even if no one hears it? Here's a thought that sticks. Some theoretical physicists argue that black holes might have hair, not actual hair. That would be both hilarious and disturbing. No, in this case, hair refers to any information about what fell in. For decades, the belief was black holes have no hair, meaning they erase everything except mass, spin, and charge. No fingerprints, no evidence. But now some are challenging that. Maybe black holes do retain some trace of what they consume. A faint gravitational signature, a residue of pattern. If that's true, you're not vanishing. You're being remixed, integrated, not deleted, sampled. And maybe the waves you generate, however faint, will ripple outward forever. Someday a civilization far more advanced than yours might pick them up. Not with ears, with something better. Something that reads the rise and fall of space-time like a record. They might listen to your fall like a lullaby from another age. Would they hear fear, curiosity, awe? Or would it just sound like a long, quiet note, the final syllable of a sentence written in gravity? Back in the quiet now, your mind turns soft. The fall continues, but urgency is gone. The noise in your head fades into something like a memory of wind chimes, half remembered and oddly soothing. You've stopped fighting the silence. It's not empty, you realize. It's full of potential sound, the kind only silence can suggest. There's no edge here. You keep waiting for something, an end, a splash, even a thud. But the black hole is nothing if not consistent. It refuses to give you that. Down here, motion loses meaning. You're not moving through space anymore. You are space or part of it. A smear across coordinates stretched thinner than thought, yet somehow still you. And still that phantom sound lingers. It no longer rises or fades. It simply persists. A gentle, pressureless hum that seems to coat everything. Like you're floating inside a cello string that was plucked once, a billion years ago, and never stopped vibrating. You wonder how long it's been since you began to fall. From the outside, not long, a minute maybe. But from your perspective, time doesn't have a clear direction anymore. It folds. It wraps around you like a heavy blanket. You could stay here forever or for no time at all. And maybe you have. This is the innermost stable circular orbit, or at least where it would be if you still had a ship, a trajectory, a mass worth speaking of. But you've passed that too. There's no turning back from here. And oddly, that brings relief. No more choices to make, just the gentle continuation of falling. Scientists sometimes describe this part of the black hole, the space just inside the event horizon, as time-like, which is a boring phrase until you think about it. You're not moving through space here. You're falling through time. It becomes the dominant direction. You're not falling in anymore. You're falling forward. A strange comfort blooms from that. The hum changes, just slightly. You feel, not hear, a modulation, like someone adjusting the bass on a forgotten cosmic stereo. The tone deepens. It expands into chords. That's impossible, of course. But what is impossible here? Maybe it's the memory of music, echoing inside a mind desperate for familiarity. Or maybe the black hole is improvising now, riffing off your last measurable heartbeat, turning you into a symphony of falling. You think of whales again, of how blue whales, the largest creatures ever to live on Earth, communicate in low, pulsing moans that can travel hundreds of miles underwater. Maybe the black hole is doing something similar, singing across the vacuum, not for you, but through you. Your presence, however brief, adds another texture to its endless song. You picture your wave, a gravitational size slipping outward at the speed of light, thinner than light itself. Not a message, not a scream, just a presence, a signature in the silence. There's a historical tidbit floating to the surface of your mind fitting, really, given your location. In 1784, an English geologist named John Michell wrote about the possibility of dark stars objects so massive that not even light could escape them. He was ahead of his time by about a century, but what's delightful is that he suggested they could be detected by their gravitational effects on nearby stars. Basically, if something invisible was tugging at a neighbor, it might be this dark, mysterious body. John Michell may not have imagined gravitational waves or stellar collapse or rotating Kerr monsters, but he did one thing right. He listened. Not with ears, but with equations. You think he'd appreciate where you are now, even if you've technically become unrecognizable. And speaking of unrecognizable, what's waiting at the center? If this black hole is a typical one, you're headed toward a singularity. That's the part no one really likes to talk about. A point of infinite density where the laws of physics just fold in on themselves and shrug. Some scientists think it's real. Others say it's a placeholder, our way of admitting we don't know what happens there yet. Historians still argue whether singularities are physical places or just artifacts of broken math. Some have suggested that what lies at the center of a black hole isn't a point at all, but a ring, especially if the black hole spins fast enough. A ring singularity, a donut of doom. Not quite as terrifying sounding, but potentially even weirder. Theoretical physicists have modeled scenarios in which falling through the center might eject you somewhere else entirely, a cosmic trapdoor to another time, another part of the universe. Not a guarantee, just a possibility. And tonight, possibilities are all you have left. Some indigenous cosmologies, particularly among the Maori and certain Aboriginal Australian groups, speak of the void not as a place of death or annihilation, but as the birthplace of the universe, a dark womb from which creation emerges. They don't talk about black holes, but their language around darkness and silence has uncanny parallels. Maybe they understood something we're only now beginning to grasp, that darkness isn't always destruction. Sometimes it's transition. You lean into that now, the hum fades one last time, not into silence, but into stillness. And stillness is different. Stillness is peace. It's quiet now. Fully, finally quiet. The kind of quiet that feels heavy and warm. The kind that wraps around you, not like a wall, but like water. No edges, no motion, just presence. Whatever this black hole was, an object, a place, a passage, it has slowed your thinking to a gentle drift. You're no longer falling. You're floating. Through memory, through concept, through possibility. Sound doesn't matter here. Time doesn't matter here. Only the drift remains. You might remember the pitch of a cosmic B flat, 57 octaves below middle C, pulsing softly from a distant cluster. Or the sound of your own gravitational whisper, lost among the waves of larger events. Or maybe you remember none of it, and that's okay. What matters is the stillness. And in that stillness, you become something new. Not a signal, not a sound, just a part of the pattern. One faint echo among countless others, layered in slow cosmic rhythm, always humming, always continuing. And if the universe ever listens back, maybe it will smile. Maybe it already has. Now drift. There's nothing left to hear, nothing left to do. Just rest.